Right, Puti. We are at the unit. What is the Puti? This is unit 2. Name of the unit is mechanics. We must know that Puti, mechanics is the most important unit of our syllabus because of Puti, mechanics is linked with all other titles of our syllabus. Right? Puti, our syllabus is consisting with 11 different units. Right? Our syllabus consisting with 11 different units. First one is with the measurements. Number 2 is with the mechanics. After that, with the waves and oscillations, light. After that, heat, gravity. These are the short forms of the titles, right? Gravity. After that, static electricity. Magnets, right? Electricity, electronics. Right? Electricity, electronics, many kind of units we are going to learn. Right? With the mechanics linked with all these titles. Right? Mechanics linked with all these titles. That's why we need to learn the mechanics properly. Right? We need to learn the mechanics that means very deeply. Right? We need every knowledge, we need entire knowledge about the mechanics because of our mathematical skills, equation skills, measurement skills, all the things are developed by the completing unit mechanics. That's why it is known as the link with all other units. Got that? That means with the forces are discussing under the mechanics. Gravity means discussing about the gravitational force, static electric force, magnetic force, like that. But the force is defined, definition of the force, what are the properties of the force, all these things are discussed under the mechanics. Got that? Under the electricity, we are discussing about the electric power. Right? But power is defined. What is the power? How do we work with the power? All these things are learned under the mechanics. Got that? That's why that's why we are considering mechanics linked with all other titles. Right? Now we are about the start of our most important basement of our subject. Got that, Pute? Right. I think many of you has the idea about what is the physics, right? But some of you don't know about physics. Pute, under the physics, we are learning about the natural environment. About natural environment? What is that? Pute, natural environment means, see this. Mula අපයට දැන් අමතක වෙලා තියෙන්නේ නේද? Our environment can be categorized into two formats. One is known as matter, other one is known as energy. What are the matter and energy? Is it okay? Matter and energy, right? But usually we are categorizing matters as, see here, right? Usually we are categorizing the matters as living and unliving things, no? But in physics, we cannot discuss about the living things and unliving things. But we can categorize them as stationary or stable. Right? Stationary things and moving things. Got that? Stationary things and moving things. Is it okay? Right? What about the energies? Kinetic energy, potential energy, sound energy, light energy, heat energy, many kind of energies. That many kind of energies we have to learn. But with all the energies we can discuss under our syllabus. But in mechanics, we are going to learn about the kinetic energy and potential energy. Right? In the mechanics, we are going to learn about only the kinetic energy and potential energy. With the stationary things, mechanics has two divisions. Stationary things are studied under the static segment. Static segment of the mechanics. Moving things are discussed under the dynamic physics. One is known as with a static physics, other category is known as dynamic physics. Got that? The static physics and dynamic physics, they're discussing about the stationary things and moving things. Can we categorize our environment? That means in the classroom environment as the static environment and dynamic environment. Yes. Are there any moving items here? Yes. ඔක්කොම තින්නේ ඒ වගේ. තව ටික දවසක් යනකොට ඩෙස්ක් බංකුත් ඒවත් moving ගන්නට categorize කරගන්න පුළුවන් වෙනවා. Right? Many of items are dynamic moving items. Right? But what are there any static items here? Static things. Yeah, all the desks, all the benches, these lab, the board, stage, all the things are non-moving items. Right? We are going to learn about how do they be stationary. Right? What is the reason for this? Stationary. How about their equilibrium? Right? About under the static segment. What about the dynamic segment with it? Why do they moving? What are the forces acting? What about the velocities, directions, all the things? Is it okay? Right. For the last week, I think we got this introduction part. No, last week we got this introduction part. Then put a right. We are about the mechanics has 8 different tubes. I think I informed that, no? Right, mechanics lesson categorized into 8 different stages. That this is our first stage, kinematics. This is our first stage about the kinematics. With the kinematics mean one is horizontal linear motion. Right, one is horizontal linear motion, other one is vertical motion under gravity. Right, vertical motion under gravity. After that, projectile motion and relative motion. Right, projectile motion and relative motion. Right? We discussed only about the first day of the linear motion. Here with the linear motion, vertical motion, these two can be categorized as one-dimensional motion, two-dimensional motion. Let's discuss about what is the meaning of one-dimensional and two-dimensional later. Right? Currently, you must know only about what is the meaning of linear motion. Right? What is the meaning of linear motion? What do you think about linear motion? Moving in a straight line. What is it? Linear motion means with moving in a straight line. That is known as what is the linear motion. Linear motion. We are about to discussing about what is the linear motion, right? Okay. Then, with under the linear motion, right? With how many pages they have to keep? Who can tell me? Can you get it? Roughly, you have to keep. ඒක කිව්වම මේ ළමයි බය වෙන එකක් නෑ නේද? 1 2 මට වැදගත්ම දේ අහන්න බැරි වුණානේ අද. ඉන්ටර්වල් එකේදී අහන්නන්නේ. ඔව්. මේ ආද යන්නේ 9 years පුතේ? කො? එයා දන්නවා. මෙයා හරි. 1 2 3 4 5 6 7 8 නියමයි. හොඳයිනේ. what about 8 days? කො? ඔය ඉන්නේ right. right. අනිත් මම හිමීට අහගෙන එන්නන්නේ. හරි. මේ ඒක වෙනම අහන්න ඕන එකක්. ඒක මම අන්තිමට අහන්න. අන්තිමටම ඉන්ටර්වල් එකේදී අහන්න. How many pages are it? 1 2 3, 4, 5, 6, 7, 8, 9, 10. 10 pages, no? Right. But you have to keep the 10 pages, 10 sides. But, right? I will provide you the note, right? මේ මම දුන්නේ නැතත් පුතේ මේ රෙකෝඩින් එකේ ඔක්කොම නෝට් එක තියෙනවා. right? රෙකෝඩින් එකේ නෝට් එක කම්ප්ලීට්ලි තියෙනවා. ඒකෙන් ඔයගලන්ට මැනේජ් කරගන්න පුළුවන්, right? මේ පුතේ what is it? Linear motion, no? මේ these things are පුතේ really familiar points, right? Really familiar terms we are going to discuss now. First one is you also, right? Answer me. What is the distance and displacement? Puti, what is distance? Distance, what is that? Length of any part between 2 points, right? Length of, this is the AB, length of any path between 2 points, that is, what is that? Distance, right? That is the distance. What about the displacement, Pute? Displacement. What is that? Yeah, shortest distance between 2 points towards a constant direction. Shortest distance between 2 points towards a constant direction, that is the displacement. Is it okay? Right. What is distance? Length of any path between 2 points, that is distance. Shortest distance between any 2 points towards a considered direction or towards a uniform direction, that is the displacement. Distance and displacement. Right? I think these things you know in your A level, in your O levels, no? Only? Right. Then distance, displacement, non-things. Puti, what about the speed? Speed. What is that? Speed mean rate of change of, what is the distance? Rate of change of distance is speed. What about velocity? Rate of change of displacement is velocity. What about acceleration, Pute? Rate of change of velocity, that is the acceleration. Right? I think all the things are familiar, no? You know these things, no? Right. Then Pute, equations. Right? Those are the 3 major terms. Acceleration equation. With the acceleration equation is with a v minus u over t, no? Acceleration equation is what is the v minus u over t. Here, a times t equal v minus u, v equal u plus at. That is the first equation. Right? This equation rearranged, right? v equal u plus at. Then, second equation taken from the velocities. Right? Second equation taken from the velocities. We have discussed about 2 different kind of velocities. What are they, Pute? One is average velocity. Right? Average velocity. After that, mean velocity. Usually are they same? Usually they are not same. Mean velocity, average velocity, usually they are not same. But when the object is moving in a straight line, right? When the object is moving in a straight line, is that all? With uniform acceleration, right? When the object is moving in a straight line with uniform acceleration, average velocity becomes equal with the mean velocity. Are they okay? Right. Average velocity, mean velocity. Finally, Pute, we got the equation is equal u plus v by 2 times t. Right. Those 2 are the major 2 equations. Right. What is the first one, Pute? V equal u plus at. Next one is s equal u plus v by 2 times t. After that, third equation, what is that, Pute? S equal, yeah, s equal ut plus half at squared. Finally, Pute, v squared equal u squared plus 2as. හරිද? ඔවුනේ ඔයගොල්ලෝ දන්නේ? Right. With the last week we discussed up to this level, right? V equal u plus at. S equal u plus v by 2 times t. Right? This is the summary of last week's session. Right? Last week we discussed up to these 4 equations and how do we apply these 4 equations. Got that? But today we are not going to discuss about the 4 equations. Today we are going to start the next topic. These 4 are the equations. Right? These 4 are the equations. We need the basic idea about the velocities and accelerations. That's all. Right? For today's session. එතකොට ගෙදරදී first day එකේ වැඩ ටික ඉවර කරගෙන එන්න. right? එතකොට next week manage කරගන්න පුළුවන් කිසිම අවුලක් නැතුව. හරි නේද පුතේ? right. Let's see. මේ online ඉන්න අයත් පුතේ මට මේ recordings ඕනේ කට්ටිය පොඩි WhatsApp message එකක් දාලා තියන්න හොඳද? එතකොට එවන්න. right. Shall I erase these things? right. Okay. Puthi last week I asked you to bring something. What are these? මොනවද ගේන්න කිව්වේ? Yeah, one is measuring instruments, but not that one. I asked you to bring the rulers, pencils and erasers. තියනවද මේවා? Not. May put write down next up. Put the newcomers, please keep 10 pages. Right? Please keep the 10 pages for the first day note. Right? ඔය විනාඩි 10ට කියපුවා පිටු 10ක් ලියවලානේ නේද? Motion graphs, right? ඇති. Right. Puthe, when we discuss about it, right, no? Right. Okay, right. Puthe, we are discussing the motion graphs. Puthe, stop the talkings now, Means right. Now see the here. And now stop, Now enough. Motion graphs. I think this is the first time you are going to learn the motion graphs. So this is the first time you are going to learn the motion graphs. But we have to discuss about 3 different motion graphs. That motion graphs are illustrating the nature of the motion. That the motion graphs are used to illustrate the nature of the motion. There are 3 different categories of the motion graphs. One is displacement time graph. Displacement time graph. Next one is velocity time graph. Number 3, acceleration time graph. Acceleration time graph, right? Put it first, right? Okay, first write this one. there are three different motion, right? There are three different motion graphs, three different motion graphs are to be discussed. Three different motion graphs are to be discussed. Three different motion graphs are to be discussed. Right? Then we list them. Number one is what is the displacement time, velocity time, and acceleration time. Right, finish now? Yes. We can write our first subtopic as displacement time graph. Displacement time graph. Right. Okay, what about the displacement time graph? The displacement time graph, they are used to illustrate the variation between displacement and time. Right? What is the variation of the displacement of an object with the time? That is illustrated by the displacement time graph. Right? Write this one. To illustrate the variation between displacement and time. Displacement and time. Displacement and time. The displacement time graph. The displacement time graph is used. The displacement time graph is used. The displacement time graph is used. Right. Right. This is my object. Right? Why? Right? This is the object I am going to illustrate. Right? I need to write. I am going to explain about some different motion of the object. Right? Because sometimes object can stay stationary. Is it okay? Now the object staying stationary. Got the object is right? Okay, see here, object staying stationary. Right? Because sometimes this object moving with uniform velocity. Because sometimes this can be moved with uniform velocity. But because sometimes this can be moved with, what is the uniform acceleration? Right? Uniform acceleration. Because there are many categories of motions. Sometimes we have to discuss about the variable velocities, variable accelerations like that. But in our syllabus, we are not going to discuss, we are not going to apply about the variable forces, variable accelerations or variable velocities. Usually we are discussing about uniform acceleration, uniform velocity, and twisting objects. Right? We need to know how do we illustrate these three categories of objects using displacement time graph. Right? Using displacement time graph. Right. So when we draw the displacement time graph, these are the major items of the graph. One is with a y-axis, other one is x-axis. Right? With the y-axis measured with velocity. Sorry, y-axis measured, y-axis is illustrating displacement. Right? Displacement. Do you know what is the unit of the displacement? What is that? Meters. Displacement measured with meters. X-axis what? X-axis measured with time. Unit is seconds. Right? When we plot a graph, it is compulsory to indicate the y-axis with the SI unit, x-axis with the SI unit. Right? Usually you are receiving 1 mark for naming the x-axis with the unit. Another 1 mark for naming the y-axis with the unit. Got that? Another one mark to denote here the origin. Got that? Another 1 mark given for this 0, 0 mark. Is it okay? Graph එක ඇතුලේ completely empty තිබ්බත් මේ තුනට ලකුණු තුනක් එන්න ඕනේ. තුනක් නැත්නම් දෙකක් ඔය ටිකට දාන්න ඕනේ. තේරුණාද? Right? What is the first one පුතේ? Y-axis with the unit. After that, x-axis with the unit. Finally, origin. With the first, write these three. That means draw the x-axis and y-axis with the names and units. Is that over? Oh, ne? Right. Well, now let's see. Here. Put I need to illustrate the resting object on this graph. Right? Non-moving object, stationary object, resting object. Today, please take out your homework books. Huh? Last week, 11 questions now. Not the theory book, homework book, right? Right, me put it, see here. What about the resting of displacement? Change of displacement of a moving object. What is that, Puti? Sorry, change of displacement of a resting object. What is that? Change of displacement of a resting object. What is that? Object is in rest. So what about the change of displacement? 0. Right? When the object is at rest, change of displacement would be 0. Puti, therefore, we can denote the resting object like this. When the displacement is 0 and the graph is parallel to the x-axis, right? If the graph parallel to the x-axis, then it can be saying as resting object. This is illustrating what is the resting object. Displacement is 0. Resting object when displacement is 0. Got that? Right. Is that all? Let's see this one. The firstly, right, previously discussed person, this is his home. Right? When he is in the home, definitely his displacement would be 0. Right? When the person is in the home, his displacement that would be 0, no doubt about that. But now he is going to where's this? School. Come on, right? He is moving here, right? But in the middle of his journey, he met a friend. Got that? Then මොකද වෙන්නේ? Two friends, they are chatting. Right? මෙතනට වෙලා ඉන්නවා පොඩි chat එකක් දාගෙන. Now පුතේ, what about their change of displacement? Change of displacement is, that is 0. That means no change of displacement when he is arriving here. But when we consider this point as displacement 0th point, this point as the final point. At this level, there is some kind of displacement. Got that? That point with a displacement is not equal to 0, but no change. But there is some kind of displacement. Got that? The somewhat of displacement, but it is not changing. Is it okay? At the x distance from the house, he is stationary. Got that? At the x distance from the house, he is stationary. With a x distance from the house, stationary person can be illustrated like this. Got that? Displacement is x, but the person is stationary. Got that? යාළුවත් එක chat එක දාගෙන හිටියා කියලා time එක නවතින්නේ නෑනේ. නේද? Always time is passing. 1 second, 2 seconds, 3 seconds, 4 seconds, not seconds. 1 minute, 2 minutes, 15 minutes, sometimes half an hour, that kind of time is passing. But the displacement is constant at the x point. Is it okay? Displacement is constant at the point x, but the time is passing. Got that? That means with this one also illustrating what the moving, this one also illustrating what the resting object, not the moving object. That one also put what is that? Resting object, stationary object. This object is stationary at x distance from the house. Is it okay, Pute? Right. Then how do we name them? This is showing what is the resting object. Resting object at 0 displacement. At 0 displacement. But this one is illustrating what the resting object at x displacement. X displacement from the initial point or origin. Right? Is it okay? This is illustrating what, Pute? Resting object at 0 displacement point or origin. Is it okay? This one is what is the resting object at the 0 displacement. But this one is illustrating what? What on it? Resting object at x displacement from the origin. From the origin, from the initial point, like that. But is it okay? Got that? Right. We take these two graphs, Pute. Take those two graphs. Right. Yasindu, what happened to you? Mepute, please keep, I think 1 page is enough, right? Keep 1 page, then start to write this part, right? Okay, is it over? Right. Now I need to denote the uniform velocity. Right? I need to denote the uniform velocity from this graph. Right? How do we illustrate the uniform velocity? එතකොට ඔන්න අද මේ මම එක දැක්කම මට මතක් වුණේ. අද අලුතෙන් ආපු අයටයි measuring instruments tubes හම්බුනේ නැති කවුරු හරි ඉන්නවද ක්ලාස් එකේ? right. ඒක මම දැන් ආයෙ රීප්‍රින්ට් එකක් දාලා තියෙන්නේ. right. එතකොට next week වෙනකොට measuring instruments tubes ටික දෙන්න පුළුවන්. මේ online ඉන්න අයටත් ඒක එවන්නම් හොඳද? Now see the next topic. This is resting object now. We are discussing about what the moving object, but moving with uniform velocity. Write the second. Next one. Moving objects with uniform velocity. Moving object with uniform velocity. Right? Moving object with put a uniform velocity. What is that? What is the meaning of velocity? Rate of change of displacement. Velocity means rate of change of displacement. Uniform velocity. That rate of change of displacement uniformly. The displacement is changed uniformly. Got that? What's the meaning of uniform velocity? Uniform change of, what is the displacement? That uniform change of displacement. No, I will write it here. Uniform change of displacement. No need to write that now. Right? But how do we illustrate the uniform change of displacement? This is one kind of graph. Right? This is one kind of graph. This one is illustrating change of displacement with uniform velocity. Sorry, change of displacement with uniformly. Got the change of displacement uniformly illustrating here. What about this one? Is this illustrating the uniform velocity? Yes. This one also, what is the? Changing the displacement uniformly. Got that? We can observe the change of displacement uniformly. But this object begins with zero displacement. But this one begins its motion with x displacement. Is it okay? This one begins its motion with zero displacement. But the next one begins its motion with, what is the? X displacement. Got that? X displacement. Is it okay? What about this one? Is that illustrating displacement? That means uniform velocity. Is that illustrating the uniform velocity? Yes or no? Change of uniform. Displacement changing uniformly or not? Again, yes. Right? This is leaving the home to the school, but this one is from the school to the home. Got that? With this one starting from the home to the school. මේ තියෙන අර යන්න ගමන් යාළුවව සෙට් වුණාට පස්සේ displacement x no. එතනින් ඉඳලා ඉස්කෝලේට යන ටික. After that, from school to the home. Got that? All are moving with uniform velocity. Got that? All are moving with uniform velocity. I think now you have the idea about what is uniform velocity. Is it okay? Uniform velocity mean what is it, Pute? Change of uniformly. That means change of displacement uniformly. Pute, is it okay? That's the star mark. Right, with a star mark. Change of velocity uniformly. Change of displacement, no? With change of displacement, change of displacement uniformly, is known as uniform velocity. Change of displacement uniformly is known as uniform velocity. Right. Okay, but take these three graphs. These three are the three different categories of graphs, but all are illustrating the uniform velocity. All are illustrating the uniform velocity. Right, that means now we are measure the illustrate the uniform velocity from the displacement time graph. But the accelerations also can be illustrated from this graph, right? Acceleration also can be illustrated here. But see here, right? I'm not going to illustrate the acceleration at this moment. right? At this moment, after the next title, we can discuss about the acceleration. Right? Let's see here little. We know that this graph illustrating what is the uniform velocity. Right? This graph illustrating what is the uniform velocity. Let's see this one, Pute. Here, I selected two different points, right? I selected two different points on the graph. This one is T1, displacement is S1. This one is with a T2, displacement is S2. Is it okay? Here, do you know the term called gradient? What is gradient means? Gradient, what is that? Your maths knowledge, O level. Y2 minus Y1 over X2 minus X1. Remember that? Gradient mean what is the? Y2 minus Y1 over X2 minus X1. This is the gradient, you know. I am going to replace these things. Again, I need to find the gradient of this graph. But the simple idea of the gradient is slope of the graph. Got what is the meaning of gradient? Slope of the graph, right? That means if the graph is in this level, horizontal, what about the slope? Are there any slope? No. So what about the gradient here? Zero. That's zero gradient. This one has small gradient, small slope, small gradient. What about this kind of slope? That is very large slope that has very large gradient. Got that? The gradient illustrating what is with the slope of the graph. The gradient illustrating what the slope of the graph. Here the gradient is y2 minus y1. y2, what is that? S2 minus the y2. S2 stands for the y2. S1 stands for the y1. So I can replace them as S2 minus S1. X2 minus X1. X2, what is that? T2. X1 is T1. Right? T2 minus T1. Put a S2 minus S1. Change of displacement. Is it okay? S2 minus S1. Change of displacement. Got that? What about the T2 minus T1? Is that change of time? Yes or no? Yes. Right? T2 minus T1 means change of time. What is this triangle illustrating? Delta or change of. Right? That is a Greek letter. That is not a triangle. That is a Greek letter. What's the name of this letter? Delta. Right? Delta illustrating what is the small change of. Delta illustrating what the change of, small change of. Change of displacement over change of time. See here, gradient illustrating small change of displacement over small change of time. That means displacement over time. Displacement over time, what is that? Displacement over time, what is that? Velocity. Now what happened here? The gradient of the graph illustrating what the? Gradient of the graph. This is illustrating what is the? Velocity of the object, velocity of the motion. Finally, we must know that in displacement time graph, in displacement time graph, the gradient of the graph illustrating what the? Velocity. The gradient of the graph illustrating velocity. Right, Pute? Write with a star mark, right? Let's write that one at the beginning. Okay, write with a star mark. In displacement time graph, right? In displacement time graph, right? In displacement time graph, displacement time graph, the gradient of the, right? The gradient of the graph, right? The gradient of the graph illustrating, right? The gradient of the graph illustrating illustrating velocity of the motion, right? Illustrating velocity of the motion. Right. Take this graph and write these things. Is it over? Is it over? That's over, no? Pujit, that's about the displacement time graph. Right? Displacement time graph. Pujit, now we know that gradient of the displacement time graph illustrating what is the velocity? Yeah, gradient of the displacement time graph is illustrating velocity. Then Pujit, write the next topic as displacement time graph. Right? Velocity time graph. Right? Next topic is what is the velocity time graph. Right? Velocity time graph. We have to do a lot of number of questions under the velocity time graphs, right? Velocity time graphs. For the displacement time graph is a vector graph. Right? Displacement is a vector. Displacement time graph also a vector graph. Here the velocity also a vector, no? Velocity time graph also what is the vector graph. Put it here. Also, I need to illustrate what are the resting object. Resting object. Put it, this is velocity time graph. Velocity v, ms minus 1. Time, seconds. Origin is 0. Put the origin is compulsory. Yeah? Put the, what is the velocity of resting object? Velocity of resting object. What is that? 0. Velocity of resting object is 0. Because the velocity of the resting object is what? The 0. Is it okay? Right. This is velocity time graph. Velocity ms minus 1. Time measured with seconds. Origin is 0. Pute, this is illustrating. Is that resting? Is that illustrating resting object? No. Pute, this object has a velocity. Got that this object has a velocity. If this is 5 ms minus 1 value, right? If this is 5 ms minus 1 value, that means, Pute, this object is moving with always constantly keeping 5 ms minus 1 velocity. It is maintaining velocity at the 5 ms minus 1 always. Is it okay? So what's the meaning of this motion? Which kind of motion here? Uniform velocity. Got that? This object is moving by keeping always the same velocity, uniform velocity. Got that? Is that okay? Same velocity. This is illustrating what? The uniform velocity. Resting object. This is uniform velocity. Right. Okay, wait for a while. This is uniform velocity now. This one is again v, t. This is the graph. Moving with v velocity, t time duration. Right? Moving with v velocity, the time duration is what is the simple t. Is it okay? Simple t, time duration. But I need to measure the area of this graph. Right? I need to measure the area of this graph. Puti, how do we take the area of a rectangle? Area of a rectangle, what is that? What is it? Yeah, that means we need to multiply those two lengths, no? One side has the V length. Got that one side has the length V. Other side has the length T. V into T. Is it okay? Height of this side is V. Length of this side is T. Here the area of this rectangle is V times T. Velocity times T. Do you have any term? Velocity into T. About the displacement. This is yeah, that velocity means displacement over time now. Product of Vt is what is that? Displacement, right? Velocity into time is what is the displacement. Vt product equal displacement. Put the area under the velocity time graph. What is the area under the velocity time graph is illustrating what the displacement of the motion. Got that? What is the? And read it loudly. Area under the velocity time graph illustrating displacement. Right? Area under the velocity time graph illustrating displacement. Right. Put it, take these two graphs. This is resting object, uniform velocity. Resting object, uniform velocity. Yes. පුතේ හරි නේද? ඔව් නේ. බ්‍රේක් එකක් එහෙම ඕනේද? කෑ ගහන්නේ හවුද? අනිවාර්යයෙන්ම නේ මොකක් නේද අපි ඒක ඕනනේ. මේ පුතේ එහෙනම් මේ 15 minutes enough no? 20 මොනවා කරන්නද? දවල්ට කාලේ ඉන්නත් වෙලාව තියෙනවා. ඔලිවට සමතෝන්නේ. ඒක අහන්නත් තියෙනවනේ. මේ හරි මේ එහෙනම් එන්න කීයද වෙලාව? within 15 minutes ඉක්මනට එන්න හොඳේ. ඉක්මනට එන්න. Right. Put this is discussing about what the velocity, no? This is discussing about velocity. What are the resting object, uniform velocity, area of the graph, right? Put it right then. Area under the, right? Area under the velocity time graph, right? Area under the velocity time graph, right? Area under the velocity time graph, right? Area under the velocity time graph is illustrating, illustrating displacement, that is illustrating displacement. That illustrating displacement. This one is again about the VT graph. Right? Again about the velocity time graph, right? Right. But I need to represent the acceleration, right? I need to illustrate the acceleration of the graph. Right? What's the meaning of acceleration, Pute? Right. Pute, what's the meaning of acceleration? Acceleration mean what is the rate of change of velocity? Right? Acceleration mean what is the rate of change of velocity? But if the change of velocity is uniform, change of velocity is uniform, then what? That is known as uniform acceleration. That uniform acceleration that means with a change of velocity uniformly. Hey, stop the talkings. කෑ ගහන්න තියද ගන්න ඕනේ. අකාල බිල ඉවරයි. ආයි කන්න බොන්න බෑ. Right. Today we are going to discuss about the uniform acceleration. Right? ඒව හැත්තකින් තියන්න දැන් බෑ. නෑ නෑ දැන් යද්දි දැන් පැය භාගයක් විනාඩි 40ක් මෙච්චරලා මොකද කරේ? ඈ? ඔක යන්න ගමන් කකා යන්න. ඔහොම ඉන්න. මේ පුතේ what is the uniform acceleration, right? Put the uniform acceleration illustrating what is the uniform change of velocity. What is the uniform change of velocity? Uniform change of velocity. Put I need to discuss about the change of velocity. Change of velocity. What about the gradient here? Then නලියන්නේ නැහැ උතන. නලියන්නේ නැහැ උතන. What's the meaning of gradient? Gradient means slope of the graph. Gradient means slope of the graph. Here the slope can be written as what is the our usual equation y2 minus y1 over x2 minus x1. This gradient means the y2 minus y1. v2 minus v1 over t2 minus t1. What is the change of velocity? v2 minus v1 mean what is the? Change of velocity. Delta v, that means change of velocity. What about t2 minus t1? Change of time. Right? Delta v over delta t means change of time. What about the change of velocity over time? Change of velocity of time means acceleration. Right? Acceleration. That means gradient of the graph. Right? Gradient of the velocity time graph illustrating what? The acceleration. Right? The gradient of the velocity time graph is illustrating acceleration. Is it okay? Right. Then write representing acceleration. Right? Representing uniform acceleration. Then take these things. Right? Representing uniform acceleration. Phone එක ගෙනවද? ඔව්නේ. අර ටික බලන්න ඉවරද කියලා මොනවා හරි. Right, you 3 new. Right, for 3 of you. I'll give you the next week the file and logbooks, all other things, right? Who are the others? You and you, no? I think all others having, no? Right. This side you and you. Are there any other Pute? Not. Right. That is the first tute of the mechanics. Right. Here we had 2 more tutes earlier. One for the dimensions, other one for the measuring instruments. Right. I'll give you them next week. Right. Next week with the file all other and all other starter pack. Right. අපිට හමුදානේ ගොඩක් ඒවා. ඔව් නේද? Only file, syllabus, those things, no? Log table. Right. Is it over? Yes. Then what about the uniform deceleration? I need to illustrate the uniform deceleration from this. Uniform deceleration. With a deceleration means decreasing of velocity. Do you know the term deceleration or retardation? Yes, right. Deceleration means with a decreasing of velocity. Decreasing of velocity minus acceleration. Right? This one is illustrating with a minus gradient. Good, that this is illustrating what is the minus gradient. See here, V2 is here, V1, T1, this is T2. Right? Changing of velocity. This is representing uniform deceleration. This is representing uniform deceleration. Again, put this gradient is what is the y2 minus y1. y2 is v2 minus v1, x2 minus x1, y2 t1 minus t2. Got that here? v2 bond with t1, v1 bond with t2, v2 minus v1, t1 minus t2. Right? Here can you observe that this gradient becomes with a minus value, minus change of velocity over time, minus gradient, the negative gradient representing what is the deceleration. Got that? Negative gradient representing what? The deceleration. Put, is it okay? Right. Take this one. Put, is it over? Right. Right. Put, is it over? Finish now? Right. Now enough about studying about the graphs. Right? What are the displacement time graph, VT graph, those things. Right? Now we know how to draw the acceleration, uniform velocity and deceleration from the VT graph. Put, write this question. This is example question number 1. Right? Example question number 1. right? Write this. A stationary motor car, right? A stationary motor car, right? A stationary motor car starts its motion, starts its journey with 2 ms minus 2 uniform acceleration. Journey with 2 ms minus 2 uniform acceleration. Right? 2 ms minus 2 uniform acceleration. Acceleration for 5 seconds time duration. Right? For 5 seconds time duration. 5 seconds time duration. Then it moves with the obtained velocity, that moves with the obtained velocity, right? Obtained velocity for 10 seconds time duration. Right? For 10 seconds time duration. Right? For 10 seconds time duration. What is the maximum velocity obtained? What is the maximum velocity obtained during the journey? During the journey, and find the total displacement traveled. Right? Total displacement traveled. Total displacement traveled. Right? Put a C here. Right? We cannot do this one using the motion equations. Right? We cannot do these things from the motion equations. The reason is with the total question is consisting with two different kind of motions. No, at the beginning it moves with acceleration. After that it moves with uniform velocity. Right? But do you remember last week we discussed only about the one kind of motions, moving with uniform acceleration or moving with uniform deceleration, all. Right? That's why last week we used motion equations. But for this kind of complex calculations, we cannot use the motion equation. That means with a motion equations can be used, but that is little bit complex. Right? Here we are going to use the motion graphs to solve this kind of question. Right? What is the nature of this motion? It is given stationary motor car. Right? Stationary motor car. Then it moves with uniform acceleration 2 ms minus 2. Right? 2 ms minus 2 uniform acceleration. For what is the time period, Pute? 5 seconds. 5 seconds time period. After that, it obtained kind of velocity. I don't know what is that velocity. But then it moves with this obtained uniform velocity. For how many? What is the time duration? 10 seconds. Right? For 10 seconds long. Right? For 10 seconds long, it moves the forward direction. Right? But then now I need to draw the velocity time graph. Right? See how to draw the VT graph. VT graph has two different axes, y-axis and x-axis. X-axis illustrates time in seconds, y-axis velocity ms minus 1. Is it okay? Y-axis velocity ms minus 1. Object begins with stationary 0, then moving with acceleration. Right? How do we illustrate the acceleration from the VT graph? What is the acceleration? What is the shape? Slope, no? This kind of slope. This kind of slope, right? Zero. This is acceleration. Mark the acceleration on the line. 2 ms minus 2. Right? 2 ms minus 2 acceleration write the acceleration on the line. This one is what I don't know what's the velocity. I'll name that velocity as v. Right? I'll name that velocity as v or v1, v2 like that. But here we have to study only about one velocity. No, I will keep it here v. After that, from obtained velocity, it moves uniform velocity. Right? By the obtained velocity, it continue the motion as uniform velocity for 10 seconds time duration. Right? For 10 seconds time duration. This motion is for 10 seconds. Previous motion is for 5 seconds. Got that, Pute? Right? 5 seconds and 10 seconds. Pute, it's better to mark the time duration, right, as a time length. That means the no need, right? Don't try to mark like this. This one is 5. This one is 15. This method is also correct, no? This one also correct. But this will be little bit difficult for our simplification methods. Got that? මේක පුතේ කේම්බ්‍රිජ් මේ මම දැන් අද කියන්නේ කේම්බ්‍රිජ් එක්සෑම්ස් වලට දෙන ගණන් වලයි එඩෙක්සෙල් එක්සෑම්ස් වල ගණන් වලයි මේ graph දාන්න මේ මොඩල් එකට. හොඳද? රීසන් එක තමයි මම කැල්ල කියන ගාන හදන්නේ. එතකොට මේ මොඩල් එකට දැම්මම ඒක ලේසි. right? මේ black color මොඩල් එකට දැම්මට පස්සේ ඒ ගණන් හදන්න ලේසි. right? but අපේ සිලබස් එක අපි ගාන හදන්නේ කොහොමද පුතේ? අපි අතින් ගණන් හදන්න අපි කැල්ල එකක් දෙන්නේ නැහැ නේ. අන්න ඕගොල්ලෝ සටන් කරන්න ඕනේ දේවල් ඕවා. නැද්ද? right? අපිට ලේසිම විදිහ තමයි මෙහෙම time gap එක දාගන්න එක. right? draw the time gap. First acceleration 5 seconds time gap, uniform velocity 10 seconds time gap. Got that? That is the easiest method. අර විදිහට දැම්මම අපිට චුට්ටක් complex වෙනවා. එතකොට ඕගොල්ලෝ මේ ගොඩක් වෙලාවට ඉංග්‍රීසි පොත් එහෙම ගන්නවා නම් මම කියන්නේ මේ අපේ සිලබස් එකට හදපු පොත් නෙවෙයි. තව තියෙනවා ඔය රොගමුන් කාස්ටර් මහ පොත් જાති මහ ගොඩක් තියෙනවානේ. ඒ වගේ පොත් ගොඩක් ගන්නකොට ඒවයි තියෙන්නේ මෙතනට 5 මෙතනට 15 ඒ දාපු ගණන් සිස්ටම් එක තමයි ඒවයි ගොඩක් වෙලාවට තියෙන්නේ. right? but අපිට ඒක අපේ සිස්ටම් එකට කන්වර්ට් කරගන්නකොට ලේසිම විදිය තමයි මෙහෙම ગેප් එකක් අරගන්න එක. හරි නේද? right. I think graph is okay. right? But how do we measure this v? How do we calculate that v? That is acceleration is given here no? How do we illustrate the acceleration from the vt graph? From the what is the gradient? By the gradient acceleration illustrating. I am going to use the gradient. Gradient. Gradient is known as delta y over delta x. Acceleration is given now. What is that? Acceleration is 2 ms minus 2. Right? Gradient representing the acceleration. That means with the gradient acceleration, that must be 2. Right? With the no need to insert here the unit. Right? No need to insert the units during the calculation. But at the end of the calculation, we have to insert the SI unit. Right? So gradient is known as 2. I don't know what is the y distance. This is the y distance of this section. This is the x distance of the section. With the y distance is v. Is it okay? This height is v. Y distance is v. X is Pute, what is the 5 seconds? S is what is the 5 seconds. Is it okay? V can be taken as 10 ms minus 1. This is the maximum uniform velocity. That maximum uniform velocity can be calculated as 10 ms minus 1. Is it okay? Right. Then Pute, I need to know what is the next question, I think asking about the total displacement, no? Yeah. Pute, can you observe that? One of triangle and rectangle here. Right? Can you calculate the area under this triangle and area under the rectangle? We cannot, right? I need to determine the area under the triangle. Pute, what's the equation for the triangle area? Half into base into height. Half into, Pute, what's the base now? What's the base of the triangle? 5. Right? Base is 5. What about the height? Height also, yeah, height is 10. Right? Area of the triangle is this one. But what about the area of rectangle? 10 into 10. Is it okay? Area of the rectangle is this side is 10. We know that now this height is again 10. 10 into 10. That area becomes 100. 25. So what about the total displacement? What about the total displacement? What is that, Pute? 125 meters. 125 meters. Pute, for the final answer, SI unit is compulsory. But in between the calculation part, no need to apply the units. But the final answers, definitely, Pute, we have to insert the SI units. Is it okay? Right. Take the graph and do the calculation part, Pute. Right. I am here the beginning. Artist point in another group packet had the idea. Then the group thing. numbers ticket තියෙනවා නේද? අර phone numbers NIC ටික කොහේ ටික? රජික දැම්මනේ හරි. ඒ ටික ඕන වෙනවා. පුතේ, is it over? හරිනේ. I'm going to use a different method to determine the area. Right? Determine the area. Put here I determine the area as one of triangle and one of rectangle. No? right? One triangle and one rectangle, right? But we see this method, now we know the final answer, that would be 125. Right? Final answer would be, what is it? 125. මේගොල්ලන්ගේ ඇවිල්ලා තිබ්බද? එක්කෙනෙක් දෙද ආවේ. මේ පුතේ, if you done the paper, please send them via the WhatsApp, right? WhatsApp as a PDF. පුතේ, what is the area? මේ see here පුතේ. Area. Me පුතේ, can you observe that this one as a trapezium? Triangle and rectangle both together. We can consider this one as a trapezium. I can directly determine the area of the trapezium. Right? Area of the trapezium. Puti, let me know what's the equation to determine the area of the trapezium. Yeah, half into sum of the two parallel sides, right? Sum of the two parallel sides, A plus B into height. Is it okay? A plus B into height. Half into, put here the A, one side is 10 seconds. Is it okay? This side is 10 seconds. One side is 10 seconds plus, put B is the other side. That is, what is that? 10 plus 5, 15 seconds. 10 plus 5, that is 15 seconds. What about the height? This one is 10. Right, now let's do this one. Half into 10 plus 15 is 25 into 10 is into 10. 10 divided by 2 is 5. 25 into 5, what is the? 125. Right? 125 can be taken directly. Is it okay? We can divide the, here we know that half, 10 plus 15, 25, 10 is here. 10 and 2 can be cancelled out by the half as 5. 25 times 5 is, what is the? 125. Directly, 125 means directly displacement can be obtained. Got that? Right, with it. Take this one. මේක තව කොච්චර තියෙනවද? ඉවරයිද? හරි මට දෙන්න කොහොමද? Right, who is Vishal? Wait, then AC එක ඇත්තෙම නැද්ද? අය කියලා දාගන්න වේද? Right, this is your first attempt about the traveling microscope now. Right, Hirusha. Abhita. ඒ ටික දෙන්න නැතුව හිටියත් කමක් නැහැ වගේ. දෙනෙත්. උෂිර. මෙතුක. Who is? Ush. You? Not. Kushan. Who is Kushan? Kushen. Usha, I think. I don't know. Seriously. And I don't know. Who is this? Is that yours? What is this name, Mane? And Barla, how do you put Bara? Usha? Sadev. Take this bag. Who is Sadev? Janul. Sanket. Dinara. 5. Akitni. Who is? Nisha. Setma. You. Minrada. You. Then Kavin. Who is Kavin? Kavin Pereira. I don't know. Kavin or Trevin? Trevin, you are. This is yours. Wait, this Hirudini. Where's Hirudini? You. Yeah, you don't know about these things now. Right. Then I talk about Lakunune by Vinipa, right? It's a name. Kisal. Who is Kisal? Sandesh. Who is Mevinu? Binura. Ah. Netumli. Tisum. Hasini. අපිට ටෙස්ට් එක තව සතියක් දෙකක් කල් දාන්න වෙයිද එහෙමද? ඒ වගේනේ. Right, let's see. Puti, now we are going to discuss today paper, right? We are going to discuss today paper. Right. Puti, I think all the online students, you are having the paper, no? If not, please let me know. Right. I need the marks. Puti, first one, right? Traveling microscope can be used to see this one. මේ lesson එක දැන් ගොඩක් අය දන්නේ නැහැ අද ඉන්න අය. මොකද ඒක දන්නේ නැතුනට කමක් නැහැ. right? ඒක අපි නිකන් අදට මෙහෙම ලියාගමු. මේ ඒ lesson එක අපි හිමීට cover කරගමු. right? එතකොට පුතේ දැන් අද මට මේ lesson එක මුල් ටික ඕනේ කට්ටිය පොඩක් නම දීලා යන්න. හරි first lesson එක ඕනේ අය ඉන්නවනේ. first lesson එක ඕනේ අය මට නම දීලා යන්න. right? එතකොට දැන් මගේ අනිත් classes දෙකේමත් ඉන්නවා first lesson එක ඕනේ තව ටික දෙනෙක් ඉන්නවා. එතකොට ඔක්කොටම මේ lesson එක යන විදිහට මම පොඩි session එක seminar එකක් දෙකක් විතර organize කරලා කියන්න. වැඩේ තියෙන්නේ next week අපිට class නැහැ. class නැතුනට කමක් නැහැ. මම WhatsApp එකට messages දැම්මොත් manage කරගන්න පුළුවන් නේද? WhatsApp through cover කරගන්න පුළුවන් නේද ටික right? next week class නැහැනේ පොයනේ. පොසන් පොයනේ අපි සිල් ගන්න යනවානේ. නෑ හොඳේ මං සිල් ගන්න යන්නේ නෑ හොඳේ. ඕගොල්ලෝ වරදවා වටහා ගන්න එපා. නෑ නිවාඩුයි කියන්නේ මේ මම කැමති නෑ අතරම නිවාඩුවක් දෙන්න. මම කැමති නැතුව දැන් ඉන්ස්ටිටියුට් එක අහලා. මේක ඕපන් කරනවා නම් මම අනිවාර්යෙන් ක්ලාස් එක කරනවා. මම 26 හරි ලොකු සෙමිනාර් එකක් දාලා තියෙන්නේ. දැන් මම දන්නවනේ මේක කොහොමවත් නැහැයි කියලා. paper. You didn't receive, no? You haven't, no? You also? Did you pass this? What about you two having with it? Yes. හරි මේ අහන්නකො දැන් මේ lesson එක කරලා නැති අය මේකට මොරි වෙන්න යන්න එපා. අපි මේ කොහොමවත් පුතේ class එක start මේ අහගන්න right? start වෙන්න කලින් මේ වගේ පොඩි revision එකක් එනවා. right? කලින් කරපු units වල එතකොට ටික දවසක් යනකම් ඒක පොඩ්ඩක් අවුල් යයි. right? දැන් මේ lessons වල revisions එනකම් but අපි ඉක්මනට අනිත් units එක ඉක්මනට cover කරගමු. right? ඉක්මනට within 2 weeks වගේ cover කරගන්න try එකක් දෙමු. right? yeah, within 2 weeks පුළුවන් වෙයි. manage කරගමු කොහොම හරි right? Put the first one, traveling microscope can be used to measure the internal diameter of a capillary tube. The main scale division is 0.5 millimeter, while 49 main scale divisions are coincided with the 50 vernier division. Find the least count of the instrument. Find the least count of the instrument. Put the, what about the least count of the instrument here? Least count. Half over. Here we have 50 vernier divisions. 1 over 2 into 50. 1 over 100 millimeters. That means what is 0.01 millimeters. The next one, right? Part B. What is the first adjustment done before using this instrument? Before using the instrument, what is the first adjustment? We have to adjust the microscope stage. Do you remember that? Microscope stage. How do we adjust that microscope stage? Adjust the microscope stage horizontally. Write this answer. Right? Adjust the microscope stage horizontally. Right? Adjust the microscope stage horizontally. Right? Adjust the microscope stage horizontally. Right? Microscope stage horizontally. And right? Microscope stage horizontally. No, not and. And right? Adjust the microscope stage horizontally using spirit level and leveling screws. Spirit level. Spirit level and leveling screws. Right? Adjust the microscope stage horizontally using spirit level and leveling screws. We need that complete answer. Right? We need that complete answer. Is it okay, Bhute? Need that complete answer. How do you prepare this setup for taking the diameter of the capillary tube? Right? How do you prepare this setup for taking the diameter of the capillary tube? We know how to draw the setup. This is the capillary tube. Definitely microscope. The axis of the microscope should be coaxial. Axis of the microscope should be coaxial with the axis of the, what is the capillary tube? Right? Axis of the capillary tube and axis of the microscope. Those two must be coaxial, or those two must be inline. Got it? Inline or coaxial. So what about our answer? Set the capillary tube. Right? Set the capillary tube as coaxial. Right? Set the capillary tube as coaxial. The axis of the capillary tube. The axis of the capillary tube and axis of the microscope. Right? Axis of the capillary tube and axis of the microscope. තව පැයක් විතර ක්ලාස් එක කරන්න පුළුවන් වෙයිනේ. යන්න වෙන්නේ වහිනවා. කුඩ ගෙනාවද? මට කුඩයක් නෑනේ. මට යන්න විදිහක් නැහැ. තව කරමු. අරන් යන්නන්නේ. හරි මේ right. Put see here. Yeah, set up the taking. What is the adjustment of the microscope should be done before take the reading? Before taking the reading, what is the adjustment of the microscope? The first question is the part B about what is the adjustment done before using the instrument. Got that? But this question is asking what is the adjustment of the microscope should be done before the reading. What is the microscope adjustment, Pute? We need to adjust the focusing knob. Do you remember the focusing knob? Do you remember the focusing knob? We focused that one. The knob here. We need to adjust the focusing knob. Right? As focus the cross wires at the eyepiece. Do you remember the cross wires? මතකද cross wires ටික ගානට eyepiece එකට පේන විදිහට අපි මේක adjust කරගත්තා ඔයගොල්ලෝ මතකයිද? ඔව්නේ. අපි එක එකනාට මේක adjustment එකක් change වුණානේ නේද? මට ආපු adjustment එක නෙවෙයි වෙන කෙනෙක්ට එන්නේ. නේද? ඒක අපේ ඇහි විදිහට තියෙන adjustment එකක්. So how do we write that one, Pute? We write this. Adjust the focusing knob. Right? Adjust the focusing knob. Right? Adjust the focusing knob. Right? As focus the, adjust the focusing knob as focus the, right? Focusing knob as focus the cross wires at the, right? Focus the cross wires at the, right? Cross wires at the eyepiece. Right? Cross wires at the eyepiece. Right? Right. Put what's next? What is the adjustment of the microscope? Yeah. Put the crosswires of the eyepiece are shown below. Right. Crosswires of the, put see here. Crosswires of the eyepiece are shown below. Draw the image of capillary tube when you observe the upper margin and lower margin of the tube when takes the measurement. Right. Put we need to draw what are the upper margin and lower margin of the capillary tube. Right. Upper margin and lower margin of the capillary tube. Right. Put do you remember images given by the microscope? They are flipped. I think I told that one. Only images of the microscope, images given by the microscope, they are flipped. That means upper margin. This is the capillary tube. This would be the upper margin, this would be the lower margin. But we can observe the upper margin. We can observe the upper margin like this. Got that? We can observe the upper margin like this. But we can observe the lower margin like this. Got that? After flipping them, this is the lower margin. This is the upper margin. Upper margin should be coincide here. Lower margin, that should be coincided there. Upper margin and lower margin. Right? They are flipped. Got that? They are flipped. But is it okay? They are flipped. Right, put the next one. Okay, the diagram of a traveling microscope is shown below. I cannot draw the diagram here. The question is, what is the mention the parts of the traveling microscope and their uses. Right? There is a question given. What are the adjustments that should be done before using the microscope? The first question repeated here. And the first question repeated here, so no need to answer the first one. But number 2 is asking what is the mention the following parts of the traveling microscope and their uses. First, name the parts of the microscope, not only the A, B, C, D. I need to know all the parts of the microscope. What is the knob A? A is illustrating what is the vertical fine adjustment. B, focusing knob. C, leveling screws. D, spirit level. D is what is the spirit level. D is spirit level. What about E? Tell me what is E? What is E? Horizontal fine adjustment. E is horizontal fine adjustment. F, horizontal rough adjustment. Right? F is horizontal rough adjustment. G, microscope stage. Right? G is microscope stage. H is locking screw. H is what is the locking screw. Do you remember that locking screw help to rotate the microscope horizontal and vertically? Right, those are the parts, right? A, B, C, D. Part A, right? Again, come to the table. A is vertical fine adjustment. What is the use of the fine adjustment? Vertical fine adjustment. Write the answer. For the fine adjustment of the vertical scale. Right? For the fine adjustment of the vertical scale. Right? Fine adjustment of the vertical scale or fine adjustment of the vertical measurements. Right? Fine adjustment of the vertical scale or fine adjustment of the vertical measurement. Right? Then put a B. Right? B. Right? B. What is that? B is focusing knob. Focusing knob what? Focus the cross wires. Right? Focus the cross wires at the eyepiece. The focusing knob use what? Focus the cross wires at the eyepiece. Right? Focus the cross wires at the eyepiece. Right? Okay. Then what about C? Leveling screws for what? Level the microscope horizontally. Right? Level the microscope horizontally. D for what? Put a spirit level. That one also what? level the microscope horizontally again. But leveling screw and spirit level both are used for level the microscope horizontally. Then put the next one, right? Part C, 2 different readings. Put the according to the first reading. Right? First reading can be taken how? First of all, we need to know before taking the reading, what is the main scale reading? Main scale reading just before vernier 0 plus coincided division into least count. Put according to the first one. See here, right? According to the first scale, what is the main scale reading just before the vernier 0? Vernier 0 is here. Main scale reading would be, is that 3 centimeters? Yes, right. Main scale reading is, what is it? 3 centimeters, 30 millimeters. Main scale reading plus. What is the coincided division? Is that 12? Coincided division is 12. What is the least count? 0.01 millimeter. 30 plus 0.12. What is that? 30.12 millimeters. I got the answer. Is it 30.12 millimeters? I got the answer. Is that? Right. Put the next one. Right. Next scale. Put the what's the main scale reading just before the vernier 0? Is that 34? Yes. Right. Main scale reading just before the vernier 0 is 34 millimeters. Coincided division is the 19. Put it. Coincided division is 19. No. Coincided division is 19. Least count 0.01. 34.19 millimeter. Is it 34.19 millimeter? Is that? Yes. Now we know the measurements. Right? 2 readings are known. So what about the measured diameter? These things are about the vertical scale, no? What is this? 30.12, no? 30.12. That means, here, this is 30.12. Stop the talkings. One is 30.12, other side is 34.19 millimeters. Got that, Pute? Those are the obtained measurement, obtained reading. So how do we take the diameter of the diameter, measured diameter? How do you determine this diameter, Pute? By adding or by subtracting which one? By subtracting. Remember that y2 minus y1. This is the diameter. And this is the diameter. From 0 is here. From 0 to 30.12 here. 34.19 here. Right? We can determine the diameter by taking the difference between them. Minus 30.12. What's the answer, Annie? Is that 4.07 millimeters? Yes, right. 4.07 millimeters. Yes. That is the measured diameter. Right? How do you increase the accuracy of the diameter measurement? How do we increase the accuracy of the diameter measurement, Pute? This is, what is this? This is the vertical diameter, no? This is the vertical diameter. How do we measure the, take the increase? How do we increase the accuracy? Measure the horizontal diameter. Measure the horizontal diameter. Then take the average of diameters. Right? Find the, first we can find the vertical diameter. It is already determined. After that we can find the horizontal diameter. If we need, the horizontal diameter can be determined. If this is D1, if this is D2, finally we have to take the average of them. That make අපිට කියන්න පුළුවන් පුතේ අර ලොකුවට multiple readings කතාව? නෑ මේකේ ගන්න පුළුවන් vertical and horizontal විතරයි. හැබැයි multiple කිව්වට ප්‍රශ්නයක් නෑ. මොකද මේ 1 2 readings දෙකක් ගන්නවා කියන්නේ ඒකත් ඉතින් multiple තමයිනේ. නේද? ඒක නිසා ඕනනම් අපිට කියන්න පුළුවන් take the vertical diameter and horizontal diameter, finally take the average of them. Right? Or take the multiple readings for the diameter, take the average of them. Got that? Take the average of them. Puti, what is the fractional error of the diameter measurement? What is the fractional error? Reading is what is Puti? 4.07, no? Right. Reading is 4.07 millimeters. What about the fractional error, Puti? Expression is delta x over x. For the traveling microscope, delta x is 0.01 millimeter. What is the measurement? 4.07 millimeters. Our answer would be 1 over 407. Is this the final answer, or do we need to convert this into decimals? No need to convert decimals. This is the final answer. That we can keep the fractional error as a fraction. Got that? Fractional error can be kept as a fraction. No matter. Then what about part D? Mention a separate measurement on the method එනකන් ටික මොකටද හදන්න පුළුවන් නේද? ඔය part C මම දැන් discuss කරපු තැනට එනකම් ඕගොල්ලෝ දන්න දේවල් ටික තියෙන්නේ. but දන්න දේවල් ටික ඕගොල්ලෝ බලන්න හරියට ලියලාද කියලා? calculation part එක කරලා තිබ්බ ගොඩක් අය. හරි නේද? calculation part එක ගොඩක් අය හරියට කරලා තිබ්බා but අර ලියන ටික තමයි නැත්තේ. ඒක ප්‍රශ්නයක් නෑ. ඇයි ඒ? මොකද තාම ඕගොල්ලෝ මේවා ලියන්න හරියට train වුණේ නැහැනේ. ඔය වගේ papers 3ක් විතර යනකොට තමයි මේක train වෙන්නේ. right? ඔය වගේ දැන් මේ අපි දැන් අද discuss කරේ මොනවාද? What are the adjustment before using the instrument? What are the adjustment of the microscope? That ඔය වගේ questions මේ ආපු first time නේ. ඒතර ඕගොල්ලන් ඔළුවේ තාම මේ ඕනේ answers ටික නෑ තමයි ඒක හරි. right? but papers 3ක් විතර ගියාට පස්සෙත් answers ටික නැත්තම් මොකද වෙන්නේ? එතකොට ප්‍රශ්නයක් තමයි. හරිද? දැන් අද ගෙදර ගිහලා මොකද්ද කරන්න ඕනේ පුතේ? ඔය ටික පොඩ්ඩක් පාඩම් කරගන්න වෙනවා. මේ අපි traveling microscope මම හිතන්නේ paper එක කරපු first time නේ නේද? අපි අනිත් ඔක්කොගෙන් past papers ටික ඉවර කරානේ. නේද? past papers ඉවර කරලා තව තියෙනවා past papers දෙක තුනක්. නේද? 2007 කරන්න තියෙනවා, 4 කරන්න තියෙනවා. ඒ ටික කරන්න තියෙනවා. දැන් මේ ඉතුරු දවස් ටික එක එක ඉවර කරමු. මේ කලින් කරා කිව්වේ? ගෙදරදී කරන් ආවා. එහෙනම් හොඳයි. හරි. ඒ ටික එක එක ඩිස්කස් වෙන්න ඕනේ. මේ හරි නේද පුතේ? එහෙම මේ what's the answer for the last one? Mention a separate measurement that can be taken from the traveling microscope other than measuring diameters. Other than measuring diameters, what are the others? We know that internal diameter of a capillary tube is okay. Internal diameter, external diameter of a rubber tube also same. What are the other measurements with it? What is the thickness of a glass slide? Making කොහොමද? පුළුවන් ඕනේ නම් අර මොකද්ද ස්ටෑන්ඩ් එකකට ෆික්ස් කරලා නටන්න පුළුවන් but thickness of a glass slide නම් අපිට ඊට වැඩි ලේසි නේද මොනවාද මේ මොනවාදනේ මයික්‍රොමීටර් ස්ක්‍රූ ගේජ් එක ගන්න එක නේද මේ කරන් නටනකොට අපිට ලේසි මයික්‍රොමීටර් ස්ක්‍රූ ගේජ් එක ගන්න එක මේ write these what they right these are the answers. Number 1 is capillary rise of a capillary tube. Capillary rise, you don't know these things, huh? Capillary rise along a capillary tube. Capillary rise along a capillary tube. Right? This is one of measurement. But the other one is right. Apparent depth. Right? Apparent depth of an image. Right? Apparent depth of an image. Apparent depth of an image through a glass block. Right? Apparent depth of an image through a glass block. right. ඒක ඇරෙන්න අනිත් ටික ඔක්කොම ඔයගලට ආන්සර්ස් ලියන්න පුළුවන්. හරි නේද? ඔව්නේ ඔය අන්තිම එක දන්නේ නැති එකක් ඒක වෙනම කතාවක්. ඒක අරගෙන ඉගෙන ගන්න තියෙන දේවල්. but කලින් ටික පුතේ ඔයගොල්ලෝ චුට්ටක් ආයි බලා ගන්න. මොකද මේ right මේ අහගන්න. ඔය ස්ටේට්මන්ට්ස් ටික තමයි වටින්නේ. හරි ඔය ස්ටේට්මන්ට්ස් ටික දිගටම දැනගෙන ඉන්න ඕනේ. රයිට්. පුතේ මට දැන් ලෙසන්ස් ටික කලින් මේ පරණ ලෙසන්ස් ටික ඕනේ කට්ටිය චුට්ටක් අකිට නම දීලා යන්න. නමයි WhatsApp නම්බර් එකයි හොඳේ. නමයි WhatsApp නම්බර් එකයි දෙන්න. පුතේ online students also if you need the previous lesson please let me know. Right? Please send me a message, right? Do you know my number? This is my number, right? What is that? Oh, right. Send me message for these two numbers, right? 268688, like that. Right. Shall we finish? Homework අද නෑනේ. ඔක ඉවරද නෑ නේද? හරි. ඒතර පුතේ ඔය අද දෙන්න තරම් homework එකක් නෑ ඇත්තටම. but මේ පොත් ටික දෙනවා. ඕක දෙන්න. Right. So stand up please today. Right. So then I go on. හරි එහෙනම් good night. පරිස්සමට යන්න. Right. So you also bye.